So this is problem 141. So in your notes right now for problem 141, you should have problem 141. And we're going to do the following. We're going to create a little table here today. So Dwayne, let's get it started. Here we go. 1/9. Let's write this next one down. 2/9. Then let's write down 3/9. 4/9. 5/9. 6/9. 7/9. 8/9. And 9/9. And I'm going to do this really quick. Now that we got this cool chart going on, what we're going to do is we're going to look at the decimal equivalents. And we'll take a look and we'll start with 1/9 right over here. And we'll do something you guys already know. We actually did it in our warm-up. And if we divide 9, that's 1 divided by 9. Then what we do is if we try to divide this, 9 doesn't go into 1. So we add a decimal point and we add a 0. And 9 goes into 10 one time. Whoops, I put the 1 in the wrong spot. But I have the undo button. Okay, so the 1 goes right there. 1 times 9 is 9. And we could subtract and the remainder would be 1. Does 9 go into 1? No. So we bring another 0 down. 9 goes into 10 one time. 1 times 9 is 9. And do you see what would happen if I kept this pattern up? I would just get a bunch of 1s forever. And so this is, in problem 141, it actually says use a calculator, but what I'm doing is just showing you what the calculator's doing and how we get this. So 1/9, rewritten as a decimal, like it says in 141, we're going to write 0.1 repeating. And the way we say that mathematically is just like I just said it, 0.1 repeating. So I'm going to draw a line here. Okay? And if we had to go to 2/9, we could say 2/9 using the same exact logic or the calculator or what the work you've already done. This would be 0.2 repeating. 3/9 would be 0.3 repeating, and most of you have memorized that. That's same as 1/3 written as a simplified fraction. 4/9, hopefully you have 0.4 repeating. 5/9, hopefully you get 0.5 repeating. And at any time you could check this with the calculator, or you could long divide it and hopefully you'd get the same thing. 6/9 is 0.6 repeating. 7/9 is 0.7 repeating. 8/9 is 0.8 repeating. And 9/9, according to this pattern right here today, according to this pattern right here, and analyzing the pattern, what should 9/9 be? 0.9 repeating. Now, at this point in time, some of you are looking at this and you're saying you did something wrong here. Say, I like this pattern, yeah, 1/9, 0.1 repeating. That's cool, that's fresh, that's awesome, that's rad, that's hip, that's killer. So the pattern works here, works there, works there, works there, and this is what I've heard from kids throughout the ages. Then they say, but at 9/9, this right here, you got something crazy going on, Mr. Small. You got something crazy. So because everybody's struggling with this right here, I'm going to offer you guys a little bit of help. Okay? Most of you are looking at this part and you're saying there's something crazy going on, but it's kind of cool and I kind of like it. I don't know where I lie. So I'm going to do some really basic math for you. You guys cool? Everybody agreed that this is correct. That if I long divide that or use a calculator, I get If I divide 1 divided by 9, I always get 0.1, and that is true. But let's analyze this further. You guys ready? So we should be doing this in our chart right now. Okay, 1/9. 1/9 is the same as 1 times a ninth. Do you agree with that statement? I definitely do. If I multiply 1 times a ninth, I get a ninth. And since 1/9 above it is 0.1, 1 times 0.1, repeating. Everybody follow with me? 1, and then a ninth is 0.1, and this is going to equal 0.1 repeating. And everybody's cool. And there's no, all this is we're proving what it is. If we look at 2/9, 2/9 is the same as 2 times 1/9. If we multiply 2 times a ninth, we get 2/9. So I'm just breaking it apart. It's called decomposing. All right, so this becomes 2 times a ninth. Well, what's the decimal equivalent of a ninth? It's 0.1 repeating. So 2 times 1/9 is 0.2 repeating. And everybody said, oh yeah. Okay, let's look at the third one. We could do 3/9, which is 3 times 1/9. And this becomes 3 times 0.1 repeating, because a ninth is the same decimal equivalent as 0.1 repeating. You guys got to focus if you want your minds to be blown away today. This is so crazy. 3 times 0.1 repeating is 0.3 repeating. You guys want me to do 4/9? Hey, don't have a bad attitude. I'll skip 5/9. 4 times a ninth. That's the same as 4 times 0.1 repeating, which is 0.4 repeating. Now that's cool. Now, could I do it with 5/9? Could I do it with 6/9? Could I do it with 7/9? All right, let's go all the way over to 8/9. We could do these, but we're assuming you guys got it already. You see the pattern? It's recording. That's cool. All right, and now we got 8/9. 8 times a ninth. That's the same as 8 times 0.1 repeating. And you guys should be writing this, remember? And 8 times 0.1 repeating is 0.8 repeating. And all I'm doing is showing you the logic behind how we get from 8/9 to 0.8, and we could actually break it down and simplify it in an alternate method, and it still works, and this is awesome. And now's where I really need you to hone in. I need you to hone in right here. Okay? 9/9. You guys ready?
Yes.
9/9 is 9 times a ninth. And you can see all I've been doing is following this pattern right here. 1/9, 2/9, 3 times a ninth, 4 times a ninth. I didn't do it there, but I could. 8 times a ninth and 9 times a ninth. And we all agree that 9 times a ninth is 9/9. So this is the same as saying 9 times 0.1 repeating. But here's where we get to a mathematically difficult part in our lives. This part right here should challenge you to the core of your mathematical understanding soul. What is 9 times 0.1 repeating? It's 0.9 repeating. That means 9/9 is 0.9 repeating.
No.
And some of you might be going, wait a second, but I thought the pattern was wrong. The pattern looked cool. It was true, then false. But what we're actually seeing is the pattern was actually correct. Because when we decompose these, like we did all of these before it, 9 times a ninth, 9 times a ninth, it is 0.9 repeating. And that means the 9s go forever. So here's what's crazy about this. We all agree that this is true. 9/9 equals 1. If you plug it into a calculator, this is what you get. Can I get an aw yeah? But now what I'm saying is 9/9 is also 0.9 repeating. Can I get an aw yeah? What that means, ladies and gentlemen, today. Oh no. What that means today is 9.9 repeating is the same thing as 1.
No way. Oh, that was the thing that we were looking at. Oh.
I just told you that 9/9 is 0.9 repeating. I just proved it.
Whoa.
The other thing that we are looking at is 9/9 is 1. We all agreed to this. And what I need to know is how many of you are challenged to your core by this right here. Okay, so last but not least, the last thing I want to do is offer you one more bit of evidence because some of you are still a little skeptical. Now that's cool. So I'm going to offer you some evidence. So what I'd like you to do is follow along with me and write this simple math problem in your notes. 1.0000000 and 0. So we have 8 zeros. Write that, please. And if you're at home and you're watching this, hey, just write it out. And what we're going to do is we're going to subtract 0.9999999 and 9. And the reason why we're doing that is really simple. It'll become quite apparent, but let's just think about this. If I told you that 10 was equal to 8, you would say you're crazy. Rightfully so. And the reason why we can prove that mathematically is that if I subtract 10 and 8, I get 2. And the fact that there is a difference means the numbers are different. And if I told you, if I followed that up and I said, hey, you know what? 10 is equal to 10. You would say, technically, you're correct, Mr. Small, because 10 minus 10 is 0. There is no difference, so this is true. And there is a difference, so this is not true. So the last thing we're going to do, the last bit of proof we're going to look at, is there a difference between 1, which we can write with infinite decimals, and 0.99999 repeating? Okay? These numbers pretend to go forever, but we're just going to look at the pattern. So here's what you're going to notice. How do we subtract 9 from 0? We use a skill called borrowing. We can't borrow from this one. We can't borrow from this one. So where do we have to go to borrow?
1.
We have to go all the way over to 1. And he becomes a 0. And then the 10 gets, and he becomes a 0 because the guy next to him needs to borrow. Whoops. Should be a 9. Excuse me. I messed up there. And then this guy gets to borrow. And he becomes 9. And this guy becomes 0. He becomes 9. And he gets a 10. And all of a sudden, we start to see the significance and the craziness that is the problem in front of us. Think about if this went forever and ever and ever, then the borrowing would also continue forever and ever and ever. And I hope at this point you're starting to notice the significance of this simple math problem. But let's look at these last black numbers. What's 0 and minus, what's 9 minus 9? 0. What's 9 and 9? Minus 0. You know what I mean. 0, 0, 0, 0, and 0. Okay, there is no 1. If we continue doing this forever that way, then these would continue forever that way. So the simple truth today is 0.9 forever is exactly the same thing as 1. And there's a short video on why.